Cool. Very good. All right, my friends, got info about next exam. Going to be, I think, a chill process. Well, I mean, it's not going to be a chill process because it's a freaking exam, but I think I've made it so that it will minimize your suffering. That was my intent. So, and also to save time, but let's just take a minute, gather our bearings, please. And maybe if you're joining in, and I hope you are, let's try that box breathing. So remember how that went? Was inhale for 4. You want to inhale through your nose for a count of 4. Hold for a count of 4. Exhale through your mouth for a count of 4. You can go right back into an inhale. You can do a 4-4-4, or if you want, you can hold the exhalation. Hold the no air lungs for 4. So you can do 4-4-4-4, or just 3 4s. Just finish up with whatever round you are on. And then let's do some calculus. If you're interested in finding some sort of endless wellspring of energy and contentment, this little stuff we do at the beginning of each class, if you practice this regularly, your life will change, literally. 10 minutes a day. Your life will turn around. Not that it needs turning around, but there's a joy that's deeper. So friends, the end of this class, in other words, noon, Exam 3, the web work portion opens up. And it's primarily web work. So Exam 3, you can think of it as 90% or so is going to be web work. And that opens today at noon. This is due a week from this Sunday at midnight. So you've got a long time to work on this. Now some of this probably you're not going to be able to do unless you've had calc before. But most of this you should be able to do after today. Toward the end, so you should be able to do, can start on everything, if you want, you can certainly start on everything, up to the application, so there's like word problems. And I'm going to show you how to do each kind of word problem, but it won't be till next week. There'll be word problems, and then there are also these problems involving related rates. So related rates, and we will talk about all this stuff on Monday and Wednesday of next week. We might even start the applications today. But I want to emphasize this. This will not be there will be no extensions. You have so long on this. If you wait until Sunday and there's a problem, that's not my problem. That's your bad choices. So this is due next Sunday. Let's get an actual date. Can someone tell me, please? It's April something.
3rd.
April 3rd, cool. Sunday, April 3rd at 11:59 p.m. You should plan on having that done well in advance. Right? Is everybody clear? No extensions, no sad emails on Sunday about how the computer shut down because I started at 11 p.m. or something like that. Yes, ma'am.
Is it gonna be the similar style of all WebWorks, like we can have as many tries?
Absolutely. Yeah. It's the best freaking exam you've probably ever had. You have complete control over this. There's no reason to not get 100%. There's bad reasons. There's really lame reasons that you don't do that. I can't help that. And then there will be a written component. So one problem that will be written, and this is due at the start, and I'll give you this on Monday. Hand it out Monday, mostly because I don't have it written right now. You've got enough to do. So get started on that. And that will be due start of class Monday, April 4th. So that's all the details. And yep, I'll hand that out on Monday. I got that written there. So this will be good. It's kind of weird because we're going to be talking about the exam material while you're taking the exam. Yep, it's all good. Get 100 on that, my friends. You have the power. So any questions at all, friends? No, does this all seem clear? Yes, ma'am.
We can still, if we need help with like the exam part, we can still ask, right?
You can certainly ask.
Okay.
I just want you to understand it. Yeah. So next week, probably next Friday, will just be like Q&A day, right? I'm not gonna lecture next Friday. I don't know yet whether that's in person or online. I will let you know well in advance. But yeah, Monday and Tuesday we'll be talking about these two things. Bless you. All right, let's get going. So we are talking today about constrained optimization. One of these problems I did in class. One of the problems on here, I freaking did it yesterday. Roughly, more or less. So, you know, you can just kind of follow through with that work. Constrained optimization. You're gonna like this. This is super well defined, super straightforward, can't go wrong. I mean, well, you know, the calculus could go wrong in the process, but if you're following along, this is one of the easiest things we've done this semester. All right, so the problem is this. Problem. Find the absolute max and min of a function f of x on a closed interval a to b. So what I mean is that we have some function, and instead of saying, oh gosh, you know, the max and min could be anywhere, we are only concerned about that function restricted to a closed window right above the closed interval a to b. So this becomes our new problem. There's a thing called the extreme value theorem. So the extreme value theorem guarantees that we can do this. The extreme value theorem says any continuous function f of x on a closed interval, and we can actually make this a more general statement, but this will work great for us, closed interval a to b, attains absolute max and an absolute min. Guaranteed. If you can't find one, then you didn't do the step-by-step process or something weird happened. Let's take a look at a specific example. And let me walk you through the process. For real, you're gonna like this. So example, ooh, g of x, really spicing things up for Friday. That's how you know it's Friday in calc class. There's a g of x. So find absolute max min. How about we just say extrema, so I don't have to keep saying that. Absolute extrema of this function on, and let's do this a couple different intervals, -2 to 3. So here's the process. One, find f prime. Right, that's not shocking. We always take derivatives. So find f prime of x. 2, find all critical values using this first derivative of f inside a to b. Note that there might be critical values that occur outside of that interval. We don't even care for this process. We're only interested in the critical values inside the interval that I was given. Step 3, evaluate, aka find, f at A, f at B. So this is the value of f at the endpoints. And then the value of f at every critical value inside AB, and f of CV for each CV in A to B. Step 4, this is the end. You make a list of these things. Whichever output value is the highest, that's the absolute max. Whichever is the least is the absolute min. So the largest output from step 3 is the absolute max. And the smallest is the absolute min, sorry. Smallest is the absolute min. That's it. So let's do it with this problem we got up here. Can you please find the derivative and the critical values, my friend? Let's practice that. Sometimes finding the CVs in that interval means you just end up finding them all and then looking for the ones, looking to see which ones fall in the interval of concern. We good on that derivative? I hope to hell we're good on that derivative. There's some bad shit going on if we didn't differentiate that properly. the critical values. All of them, not necessarily the ones of. Here, or yeah. Just say what?
Square root of 2 plus.
Plus or minus root 2. Yeah, perfect. So a couple ways to see that. One is you're just a magician, a mathematician, and you see that's the difference of two squares. X equals root 2 or negative root 2. So this is one route, or you just shift that 2 to the right-hand side. If you're the one taking the square root, you'd better pop a plus or minus on there. That goes for any even root that you take. There's always two options, two branches, to be technical. Or I could use the quadratic formula, God help me, and I'm not gonna do that. But I could, and one could. So we've got plus or minus root 2, and I would actually, plot these things out. So look at our current interval. It goes from negative 2 up to 3. And then I just have to figure out which of these fall in there. What's the approximate magnitude of root 2?
1 point.
Something. A little bit higher, but hell yeah. 1.4? Yeah, 1.4. That's a good root to know. No, root 3 is like 1.7. Those are good common things that pop up a lot. So this is like approximately plus or minus 1.4. We don't even need to know that, right? We know it's somewhere between 1 and 2, and we're good to go. And we see that both of those roots fall in here. So here's negative root 2, and here's positive root 2. So we gotta check everything. So I'm done with the calculus. At this point now, I've got 4 different values I need to find. I need to find the original function, g here, bless you, at each of these points. So let's see, that was step 2. Step 3 is I'm going to start at the left and just work my way across. F of negative 2 is a third times negative 2 cubed minus 2 times negative 2 plus 2. That's negative 8/3 plus 4 plus 2. And let's see, so that's negative 8/3 plus 6. This is 18/3, so this is 10/3. And then we've got f of negative square root of 2. This is going to be not nice and clean, but it's going to be all right. I'm just plugging that in. Square root of 2 cubed, think about what that looks like. It's 2 square roots of 2. So this becomes, and there's a negative in there, so this is negative 2/3 root 2 plus 2 root 2 plus 2. I can join these together, and let's see, so that's 6/3 is like 4/3 root 2 plus 2. That looks okay, and then we got to do positive root 2. It's going to be roughly the same computation, except these are going to be pluses in there. And so this is going to be all this stuff just with no negatives, and this is going to become a negative. So this will be 2/3 root 2 minus 2 root 2 plus 2. So this is 6/3. When I subtract it off that, I get negative 4/3 root 2 plus 2. And then finally, thank goodness, we've got a nice whole value. So f of 3 is 1/3 3 cubed minus 2 times 3 plus 2. And then, good Lord, let's see. So this is 9 minus 6, that's 3. We get a 5. So let's take a look at our output values, because at this point we need to figure out who's the highest, who is the lowest. 5 looks pretty tall. out of these numbers, but I'm gonna try to do this without a calculator. So I know that root 2 is like 1.5, right? It's a little under 1.5. So this is like approximately 3/2. So this is like 2 root 2 plus, or no, this is like 2 plus 2. This is approximately 4. Could someone actually do the calculator for that, please? Just for safety's sake.
It's like 100 or something.
Yeah, I hope, boy, I hope really that's gonna be bad. We're gonna cancel class for the rest of the semester if I'm off that bad. So you can hope, and then this should be approximately -2. And this is like,
Roughly 3.8.
which one, 3.8?
Yeah.
Cool, all right, I was very okay, I feel good. I feel good, we're gonna keep having calculus, so that's like 3.8, and then this must be like -1.8?
I don't know, maybe you just killed your patient.
What?
I said maybe you just killed your patient.
No,
with that
no.
estimation.
It's like 0.1.
What is it?
Wait, hold on, give me a second.
Okay. I got this one, that's 3 and
It's
a
like
third.
0.1. I think I did that wrong.
I don't know about that, let's see, so that's 3/2. Oh, that actually could be, that makes sense, Amma. Yeah, because this is like -2. Yeah, pretty bad. Still not bad enough to cancel class or call the patient deceased. So 0.1, I'll buy that, that sounds right. All right, so the winner is 5, that's clearly the max value. Minimum value is that 0.1. And that's it. So now I report these results. I should have put that as step 5. Report the results. Step 5 is summarize. And what you want to say here is we have an absolute max of, and you tell the output value 5 at x equals, and then where x equals 3, and an absolute min of, and don't give this approximate shit, right? We just did that to figure it out. Give the precise, beautiful answer, 2 minus 4/3 root 2 at x equals root 2. Done. Always give exact answers. Never give anyone. If you're doing a report, you're doing something official and it involves numbers, never give approximations. Never give that. Give the reader the entire number so they can determine the precision. Just good advice in general in the sciences. Give the most information possible. Any questions? Pretty straightforward, right? Not bad. Let's try one. What happens if I take this problem and I change the interval really quick? And so let's just talk about this. What if I changed this to -2 to 2? How do things change here?
The max will change.
Yeah, right, it's because I don't have 3 anymore, yeah? Exactly, so I've removed the 3. What do I need to do? What do I need to do to add 1? I need some extra info here.
Just put it in step 3. You just put a 2 in for f of 2, and then you pop out whatever number that is. That'll be your
Exactly.
new max if it is the max number.
I have another question that has nothing to do with
Yeah,
this
yeah.
technically. So what if it was sine, like if it was like sine something, it would turn into trig. I don't know, I really don't like trig functions, so I just want to prepare myself for the that's
You,
it.
you understand we're going to do a trig now. So it's okay. We got to fearlessly, just go where we're afraid. We'll do that next. It'll be okay. You're gonna be okay. We're all gonna be okay. So look, I don't have f of 3 anymore in that case, so I need to evaluate f of 2, which is going to be kind of this same computation here with a +2. So positive 8/3 minus 4
Plus 2.
plus 2, and then that's,
8/3 minus 2-ish.
yeah, so that's negative 4/3. Right, because this is 12/3. So negative 4/3 plus 2. And then this is 6/3, so 2/3, I think. So f of 2 is 2/3. How does that compare? Has anything changed? Do we have a new max? Do we have a new min? Yeah, Juan, you're saying, you shook your head yes, Juan, whether or not you wanted to.
So the new max is gonna be minus square root of 2, and
Yep.
then the new min, the min just stays the
Min's
same.
the same. Yeah. So does everybody see that? The endpoints really are important here. So I've got to check those. If the interval is this, then we have a min. Let's see, what was it? Oh shit, I lost. Oh, right there. Min of 2 minus 4/3 root 2 at x equals root 2. But now a max of 4/3 plus 4/3 root 2 plus 2 at x equals negative root 2.
So the new max is f at negative root 2.
Yes, sir. Yep. This is good. We can do this. Oh, I know what kind of problem we should do. Now I don't want you to get angry at me because I know what'll happen. But let's try. Oh, sorry about that. I'm happy to restate that if you need that. So let's find the absolute extrema. Let's practice that language of f of x equals. Just give me a second because I'm making this one up. I don't think I have.
Could you make up a random one and it would work? Or does it need to be-
I could. You can't go wrong, but I want it to do something special, right? Like I want it to be interesting, so I got one. I think I've got one. And actually, it looks like old past me. Old Timmy came up with this one. On negative pi over 2 to pi over 2. Let's have fun, trick fun, or whatever it is you view it as.
You should have that one written question we have in the exam, be like graph sign by hand. Just to see if we're paying attention.
That would be, I hope that wouldn't be hard, but you never know. Yeah, and even the written question, you're gonna be able to work on at home, right? So it's not gonna be an in-class written part. So no pressure. What are these called again? Remarkable. Okay. Yeah, that's so sweet. Yeah. Can you like send your notes somewhere? Oh, yeah, nice, okay.
Not even sure.
There won't be any factoring, so that's good. I'm glad you don't know how to do that, because that would, if you did,
There'd be a problem.
that would be a real problem, yeah. Let's just make sure. Yeah, okay, good. That wasn't a problem. There is no fraction here. these are defined everywhere, so we're not gonna have the critical value that comes up from f prime being undefined. So we're only gonna have places where this is gonna be 0. Does that make sense, what I just said? Make sure that makes sense, because you really need to understand that to minimize your suffering in this calculus life. This can't blow up, there's no asymptotes, you know. Look at a cosine function, oh, it's so beautiful and regular. Look at a sine function, oh, yes, wonderful, yes. And neither one of those blow up anywhere, so we're not gonna have this thing be undefined. But we are gonna have it equal 0. And that, I imagine, is where things are getting weird for you, Alex, and not just.
Is it just exactly where 0 would be, you know, for each function?
No, no sir. It's a little more complicated than that, and let me show you what I mean. So you set this thing equal to 0, and if you're working on this, please just go ahead and try to tune me out if possible. So with this, I would actually move one to the other side. So this means negative sine of x equals positive cosine of x. So what I'm actually trying to find, Alex, is where in the graph the sine of x is exactly the same value as cosine, but negated. So in other words, I'm looking for, let's see, so cosine looks like this, and then sine looks like this. So I'm looking for a place like this, that x value, where they're equal but opposite signs. They're equal magnitude but opposite signs. And to find that, I gotta do something besides the graph. Any suggestions on what I could do here? How would we solve this?
Could we just plug values we know, like pi over 2 or 2 pi, and see how close they are? Just kind of like.
Oh, that's an interesting approach. We can do better. We can literally get right to the answer. I like that. That's a very algorithmic approach.
Yeah, I just have no idea, so I was like, just plug.
Yeah,
shit
no, we can do
works.
better.
Okay.
How do I get right to the heart of this?
With tangent.
What's that?
With tangent.
Yeah, so that was it. What?
No.
Okay. Yes. So Juan is suggesting we divide both sides by cosine. I believe that's what he is suggesting. And that's tangent. And in fact, let's move this. Tangent of x equals -1. Get that negative to the other side. So I have to find all the places where tangent equals -1 that are in that interval. So let's actually just solve this first for everything, and then pluck the ones out that we need. And this is going to be a refresher. Tangent equals opposite over hypotenuse. That's the thing of interest to me. Let's remember this. This is going to be a blast from the not too recent, not too distant past. Yeah. So I'm looking for where tangent can be negative. So it can't. So they're all positive here. Tangent's positive here. Tangent could be negative here. Tangent could be negative here. To get opposite over adjacent, now check this out. This has got to be the opposite over adjacent. That means they're the same length. The opposite side and the adjacent side are the identical length. That means it's good old 45-degree triangle time. So I'm going to come up here and say, all right, here's this. So label this triangle because that's a special triangle. And then this one here. Notice how the opposite and adjacent sides are opposite sign, equal magnitude, getting us just what we want. And that's root 2. So this is one of our solutions. This is pi over 4 in that little nook. And then say in this little cranny, I just really wanted to say nook and cranny, like publicly. These are both pi over 4. So this is pi, back up pi over 4, 3 pi over 4 is that angle. That's clearly not in that interval because our interval goes from up here down to here. That's the place we're looking, and we see our answer right here, negative pi over 4. So check that out. That's negative pi over 4, the way we're measuring here. And that's the only place this can happen. So my critical value in that interval is just pi over 4. Negative pi over 4. Let me stop for a second.
Your second value should be pi over 2.
Yes, yeah, we're gonna definitely do those endpoints, yeah. So this is just the critical value. And then the endpoints are negative pi over 2 and pi over 2. So we'll plug everything in a minute. I wanna stop and find out if this is okay.
Why does it say negative pi over 2 and positive pi over 4?
Oh, cause, yeah.
I thought that was supposed to be 2, that's what I was saying.
Oh, I gotcha. You are correct, sir. Yeah, thank you. Okay, so now I'm gonna evaluate f at all those, the pertinent points. So f at negative pi over 2 is negative sine of pi over 2 plus cos pi over 2, 0, negative 1. F of positive pi over 2. Oh, let's do the middle value first. So negative pi over 4. What's that going to give me? You finish these up for me, please. Oh, this should have said negative. Shit. Bad move. That should have been negative pi over 2. That's 0. That's negative 1. So this is actually positive 1 because sine of negative pi over 2 is negative 1. So sorry about that. What's this middle one going to be, though? This one's going to be dead. Here, I think. Well, maybe not. This isn't dead. What is that value? This is negative 1. Okay. Oh. Just gonna have some tea. Wait for somebody to help me out. Cheers.
Is it 0?
Yes, thank you. I didn't even get a sip of tea.
I'm sorry.
No, it's okay. Yes, ma'am. It is 0. They're equal and opposite, equal magnitude, opposite sign, so absolutely. So now, we got a pretty clear path to victory. We're gonna have, this is our absolute max, and this is our absolute min. So, absolute max of 1 at, bless you, at negative pi over 2, absolute min of negative 1 at x equals positive pi over 2. Good to go. Didn't even need the graph, don't need any pictures. This process just works itself through. I think we should do one last one, but I want you to tell me how that feels.
Feels like I wanna write down all the trig values on the sheet, the
You
more
should.
trig values.
I think that's not a terrible plan. Just,
So you said that the critical value was x equals negative 4, but your equation is said sine of positive pi over cosine.
oh shit, yes, thank you. Good call, Callie. Luckily, it still turns into 0,
Okay.
but yes, excellent, important detail, thank you. Dropping signs like Galileo dropped the orange. So, does anybody know what that line is from? This is like, cause this is like old people shit. It's from a Beastie Boys song? No? Dropping science like Galileo dropped the orange? Paul's Boutique, that album? No? Okay. Just cooler than you all. That's sad. All right, your turn. Find the absolute max, min, blah, blah, blah. Function. On 0, 3. This one's for you, Kelly, a little e-practice. You really should get an award one. Like seriously, I'm gonna email you. Who's your coach? Okay, cool. Okay. You are literally the greatest golfer student who has ever passed these halls. For real, man. Like, you're awesome. I appreciate you greatly. Going good. Just checking derivatives. Yeah. Going good. He goes looking for some, maybe a formula. Yeah. Good. Quick. Does mine look okay? Yeah, let me check. Oh, no, it does not look okay. What are you? How are you doing it?
Well, that's one, and then I was using this.
Yeah, but what did read that expression?
The bottom one,
Top of the original.
x times,
Oh shit.
ooh, my bad.
There you go. Good. Just make it look solid. Yes. No, because you have to take the derivative of the exponent. If it was just e to the x, absolutely. Yep. No. That expression to me, what does that say? Yeah, so sometimes. Yeah, that looks it. Should just be getting 1 as our critical value.
I have a question.
Yes, ma'am.
So you set everything to 0, like anything that you have,
Yeah, exactly. Unless it's a fraction, in which case, if it's a fraction, you set the top equal to 0 and the bottom equal to 0. But so everything still get set to 0.
Okay.
But yeah.
What if x was 0 in the e to the x, e to the negative x?
Yeah, that still doesn't get you 0 though, right? Because e to the negative, that's just 1.
E to the 0?
Anything e to the 0 is 1. Yep. You can't raise something to a power and ever have it be 0. You can only have it be very small. Once you get that critical value, and if you want me to go through that computation, more than happy. We just have 3 simple points to evaluate. And then maybe some judgment calls, unless we have a calculator. I don't think we need a calculator. This is around a third. More than a third, because this is smaller than 3. This is like 3 over 3 cubed. So this is around a 9th. And from there, I'm good to go. I have an absolute min of 0 at x equals 0. I have an absolute max of
1 over E.
1 over e, thank you. 1 over e at x equals -1. Positive 1. Yep. Indeed. Dope. Probably have some problem like that on the web work too, I think. Something like that. I tried. Lord, how I tried. I want to actually do one application and call it a day. And then you'll actually be able to do this application on the web work if you want. But wait, before I erase anything, anybody want to talk about any of this? Good. All right, one of my favorite creatures in the world are goats. I freaking love goats. They just have really crazy, cool eyes, right? You ever seen goat eyes? They're just amazing. There's no creature in the world that looks as cool as a goat. So I'm gonna get some this weekend. I'm gonna get 2 goats, I think. And I'll probably spend most of the weekend building a pen for them. I don't know if you can tell, but this is all bullshit. But, so I've got about 120 feet worth of material of fencing.
5.5 foot planks, cedar.
Come again?
5.5 foot cedar planks.
Absolutely, yeah, because I stole it from someone because I couldn't afford it otherwise, but, yeah. Yeah, so my neighbor's like, where's my fence? He's got a new fence. That looks a lot like my fence. So I got 120 feet of fencing, and I want to create a pen for my goats to keep them safe primarily, not to control them, be their owner. I don't believe people can own other things at all of any type. So they're going to be my friends. I want them to be happy. So I'm going to build a pen just like this. Is a top view, obviously, I would say. I want this to have the most area. So 120 feet of fencing, so I want to build this 2-compartment pen. So that it has the most space with the greatest area. That's my problem. So in other words, I want to maximize the area. I have a constraint. I have 120 feet worth of fence. So this is a constraint that we have to put into mathematical terms. And what I want to optimize is this. So this is called the objective. The thing you want to maximize or minimize. All right, so what are the dimensions that accomplish this?
You want 2 perfect squares.
Maybe. Maybe. Let's see. Let's see. Let's see if you're right. That's probably right, because squares are the thing, right? But let's use calculus. Let's use calculus to get there.
Not
'Cause
our brains.
No, I mean, it's just guessing otherwise, right? Unless you can provide me with a like solid argument that that is the optimal area, besides just gut feelings.
I've just built fences before, and if you want the most space, like squares usually,
Yeah, let's
not
see,
rectangles.
let's see,
Alright,
okay? Let's see what calculus says.
alright.
So we know what Alex says. Let's see what calculus has to say. So I'm going to have to put some variables in here. So I don't know how wide that thing's gonna be. So we're gonna make that x feet. And that means each of these then has to be x feet. So in constructing these three walls, I've used 3x feet. Right, so just for this, so that's what I've used up. That means I have 120 minus 3x left for these two walls. Right, just using some simple stuff. So how long will each of these be? Because I have to divide that in half, split it between these two. So does this look right? I took half of that. Make sure you understand where I got that from. Took half of this. This is the total amount of fencing left after the 3 walls, x feet long. We're gonna cut that in half and make half of it that wall and half of it that wall. I don't know how we're gonna get the goat, we're gonna like airlift the goats in, I guess, or something like that, because there's literally no door on this thing right now. But hey, it's all bullshit anyway. Okay, make sure that makes sense. This is, now we gotta rock and roll here. We're gonna do some calculus. So, what is the area of this thing? So my area is what? What's the function?
It's gonna be, what is that? X times 60 minus 3 over 2x.
Beautiful. Yeah, length times width. So notice how this goes. We set something that we don't know with a variable, assign a variable to it, work out all the other things based on the configuration of the problem, and then come up with our objective function based on whatever it is we're doing here. So here's the function I want to maximize, but I also have some constraints. Like, let's just think physical reality. What is the least x could be?
Like a foot, I guess.
Well, let's not get too realistic. Like all mathy realistic. It can't be negative, right? So I guess I'm thinking like this. The least it could be is 0 because x is a length, right? Can't have a, so it could be 0, which would create one hell of a tiny pen. That's called a strip, right? So that's not going to hold anything in. But let's create a constraint. What is the most it can be? Ooh, what was that? What? 120. How'd you get 120? That's really lovely.
Because that's how much fencing is available.
Oh, true. But how could this shape, so we can do a little bit better. 120 is totally legit, but we can do better because we know that these both have to be positive dimensions, right? So I know that this side here, this side and this side have to be,
So infinite.
no.
There's 60 minus 3 over 2x.
Yeah, do you see, but check this out. This has to be true, right? I have to have a positive length. So that's gonna set a constraint. I want a positive side here. So we've got 60 greater than or equal to 3/2 x, and then multiply both sides by 2/3. And so then
Why
that,
2/3?
because I'm solving for x.
Okay. Would it be 3 over 2, not 2 over 3?
You multiply by the reciprocal.
Oh,
if
just
you're
kidding,
getting
kidding.
a function.
That's good, good joke. I like it. X has to be less than or equal to 40 feet. Oh my God, I have a constrained optimization problem. Life becomes simple. So we go through and we do the things we do. I would actually multiply this out to make it so I don't have to use the product rule. Could. So, yeah, that. So find the derivative. Set it equal to 0. What do we get for x? I accept your apology. 20, yes. Does that sound right? 20? Yeah, okay, good. So we got 20 feet, so that is our critical value. So now, we just have to evaluate what is the area when a side length, this is gonna be kind of dumb, but we're gonna do it anyway. Side length is 0, what is the area when a side length is 20? And then what is an area when the side length is 40? What is the area of that thing when the side has length 0? 0. I mean, look at the area. If you can just come up here, right? Just plug 0 in there. Plug 40 in there, what do you get? 0 as well. And then A of 20, now we actually have to do a little work here. So we got 20 times 60 minus 3 halves times 20. And I believe that's just 30. So I've got 600 square feet. And let's take a look at what dimensions that produced for us, Alex, and see if your intuition was right. So the thing that we're creating is going to have width 20, so 20 feet there, 20 feet there, and 20 feet there. And then how wide are these walls? Well, let's see, this is gonna be 60 minus 3 halves times 20, so 30. Is that correct? Yeah, so 30 feet. This way and this way. Alex, are those pens square?
No. I could show you a simple math problem that makes it, will make a square square.
Well, I could do that too. I could do that too. But this one isn't square.
It's just because of the 2 compartments.
Yeah. Yeah, if we have a single square, you're absolutely right, that for a rectangular perimeter, purely rectangular, then a square gives us optimal length. But that middle wall throws off everything.
Okay.
Your goats are gonna get cheated. You don't want that. Nobody wants that. So check this out. We got, yeah, this guy's like 20 by 15, right? 20 by 15, 20 by 15.
So you,
Who's-
oh, me, it's.
Oh, hi, okay, sorry.
So then basically what you're doing is just putting the highest, the one that has the highest, X value, or the endpoint, if that makes sense, into the equation that you originally found.
Yeah, so I'm using that procedure we did last time.
Okay, right.
Yeah, exactly. Just like plug in the endpoints, plug in the critical value, whoever's the most is our winner.
Oh.
Yeah, it's pretty straightforward. Alrighty, friends. You will have some goats to create houses for in that web work. I guarantee it. Thanks, everybody. See you Monday.
Well, actually,